Okay, here's a quick video lesson on how to multiply radicals. Question number 1 asks, how do we multiply monomial radicals? Monomial means one term, right? One term. So there's 1 and 1. Those are monomials. Well, the way that we multiply them is we multiply the numbers or terms under the radicals then simplify. Keep up on the notes because I can't pause because this is a video and not me. Alright, so I'm going to give you an example. For number 2, radical 3 times radical 3, I'm going to multiply what's under the radicals, so that's going to be radical 9, and then simplify. So the square root of 9 is 3. Number 4, radical 2 times radical 6, that's equal to radical 12. Remember how we simplify these. This is a square root, right? So we're looking for things like x squared or whatever. So what perfect square goes into that 12? 4, 9, 16, 25, etc. The only factor that goes in is 4. So I can split this into 4 times 3. So all square rooted. 4 is equal to 2 squared. So I can rewrite this as 2 squared times 3. And then the same old bouncer letting you off the line, letting you in analogy. The 2 has an invitation. So he gives it over and he's allowed through. My final answer is 2 radical 3. On the last example, I picked number 13 because it looks a lot more complicated because it has these numbers in front. Those numbers in front are coefficients. When you have coefficients, you just multiply them times each other as well. If there is no coefficient, assume it's a 1. So like, back to a different example. If I was multiplying like for number 6, right? 2 times, oh wait, there's no coefficient here. There's basically an imaginary 1, so it would be like 2 times 1. If I'm doing number 13, this is 4 square root of 6x cubed times negative 3 square root of 8x squared. I'm going to multiply the outside times the outside. 4 times negative 3 is negative 12. I'm going to multiply the number times the number. 6 times 8 is 48. And I'm going to multiply the variable times the variable. X to the third times x squared is equal to x to the 5th. And now we just simplify this. 48 can be broken up into 16 times 3. We know that we want 16 times 3 because this is a perfect square. Right? These are square roots. So this guy is going to break up 16 times 3. X to the 5th becomes x squared x. I can rewrite 16 as 4 squared. And now we can do a lot of simplifying, bring a bunch of things out. So who can come out? He can, and he can. So cross out all those exponents, all those invitations. And the 4 gets to come out, and the x gets to come out, and the other x gets to come out. So in the end, I've got negative 12, 4, x, and x on the outside. Underneath, I've got the 3, and this x over here. So my last simplifying step is negative 12 times 4 is negative 48. X times x is x squared, square root of 3x. Now you do numbers 1 through 15 due Monday.